Hello friends. So in today's question, a man of mass 60 kg is standing on a platform of mass 20 kg. With what force F a man pulls on a rope in order to support the platform on which he stands? With what force N does the man press the platform? What is the maximum weight of the platform that the man can support? So in this case, this is a figure. So man which is trying to pull this rope with the force F, and this is the platform given. So this is the platform, and we have two pulleys, 1 and 2. Okay, so let us analyze the different situations or with the help of free body diagram. Okay, suppose this is the man, okay, and we say that capital M is the mass of the man and small m is the mass of the platform. So we have a man which is going to have mg in the downward direction, okay, and because of the platform it is going to have a normal in the upward direction, and we can also see that it is holding to a rope, okay, and so we assume that there will be a tension which will be in this rope, okay. In this case we assume that let there be tension of T2 in this the rope. So we can write the equation with respect to all the forces, okay, and it is not given that there is some kind of acceleration in it, so it means it is in equilibrium. So we can say that for the man to be in equilibrium, for the man to be in equilibrium, the force which is exerted in downward, that is mg, will be equal to the tension force T2 in upward direction plus normal, okay. So let this be equation number 1. Second, we draw a free body diagram for the platform, okay. So let us say this is our platform. So in the downward direction we are going to have mg, and in platform it is connected with two ropes, okay. So you can say let first rope will have T1 and second rope, this is same rope which is connected, which is rather pulled by the man, so it is also going to have T2, and there will be a normal which is in the downward direction, so this will be N, okay. So let me write it here, FBD for man, okay, and this is FBD for platform. So we can write the equation, and we can see that N plus mg will be equal to T1 plus T2 and let this equation be equation number 2. Next we have a pulley, that is pulley number 2. Okay, so we can draw the free body diagram for the pulley also. And this will be our, because it is same string which is connected to the platform, so this will be T1, and we have here T2 and T2, okay, which are connected. One is pulled by the man and another one is connected to the platform. Okay, so this is, we can say, free body diagram for pulley 2. This is pulley 2, and we can write that for equilibrium, or we can say under equilibrium, in pulley 2 we are going to have T1 is equal to 2 times T2. So let this be equation number 3. Okay. Now what we do, we add equation number 1 and 2. Okay, adding equation 1 and 2, we get T2 plus N plus T1 plus T2 is equal to mg plus n plus small mg. So in this case this normals cancels out and we get T1 plus twice T2 is equal to, we take a g common, this will be m plus capital M. And we already know that T1 is equal to twice T2. Okay? So we can write from equation 3, we have substituting value of T1 as twice T2. This will be twice T2 plus twice T2 is equal to G M plus capital M, or we can say that T2 is equal to G upon 4 M plus capital M. Okay. And we all know that F will be nothing but our T2. Okay, so here we can say that F will be equal to T2. So if we substitute the values, we can say that F is equal to T2, and which will be equal to G by 4 M plus capital M, and we are supposed to take G as 10, so G by 10 by 4, and this will be 60 plus 20, and this will be giving us as a 200 newtons. This is our first part, in which it is supposed to find out what will be the value of F. And the equation 1, you can say from equation 1 we can write that n is equal to mg minus t2, and t2 is nothing but our f, so we can say that f mg minus f. Okay, and we can substitute the values. So we are going to get this as mg minus m plus m divided by 4 into g, which is nothing but f. Okay, we substitute the value of f, and if we take the LCM, we can take g as common. This will be 4m minus m and minus small m divided by 4. So this will be coming as g by 4. We have 3m minus small m. Now we substitute the values. We get n as g is 10, that is 4, and we have 3 into 60 minus 20. This can be written as, or rather we can solve this as 10 by 4. We have this as 180 minus 20, and this will equal 10 by 4. We have this as 160. Okay, and we can cancel out. This will be our 40. So we have a normal which is equal to 400 Newton. This is our second part which we were supposed to find out. Okay, and it is also supposed to find out what will be the maximum weight of the platform that the man can support. Okay, so we are going to find out the maximum weight. So we already derived the equation. Let me write it here. We have written that mg is equal to thrice mg minus 4n. Okay, we can simply solve this equation. This is nothing but n. From this we can find out mg. Let me call this as equation number 4. We can say from equation 4 we get mg is equal to 3mg minus 4n. Now we want that the maximum weight of the platform. Okay, so mg is nothing but the weight of the platform. So mg will be maximum when normal will be minimum. Okay, so you can say the weight of the platform, that is mg will be maximum when normal is minimum. Okay, and the minimum means that is normal is equal to 0. So we substitute the value. We want mg to be maximum, so we can write mg maximum will be equal to 3 times mg, and if you put the values, this will be 3 into capital M is given as 60 and G is 10. So we get mg maximum will be equal to 1800 Newton. So this is our last part. Okay. So this completes the question. Thank you.